Professor, and I am Ravi Kumar, a PMRF research scholar at IIT Mumbai. In this course, we have understood working and fabrication of a solar cell. So we have seen different kinds of solar cells, but today's lecture is like something about the technology which we need while fabricating a solar cell. So as you can see in this picture, there are some solar modules. So what do you think? What should be the width of those, or like depth, or we can say the width of those solar cells that are in the solar module? How much thin it can be? Have you seen some bare solar cell without in a solar module? Am I audible? Am I audible?
Yeah, you are audible.
Some magnetic material, and we just have a solar module. Cannot have solar. You can see this is fragile, the part of solar cell. I just wanted to show you a solar cell. Well, if you can touch it, then you can feel how thin it is and how fragile it is. Okay. So as I told you, in this class, we don't have anything related to solar PV, but we have something related to the process which we need in the fabrication processes. So before going to those things, we will just recap what we have learned in this course. Yes. So first we started with the semiconductor. Even we started with solar energy, then types of solar energy, then energy on the environment, why it is renewable and all. And technically we started with the semiconductor, then p type and type. We have question why is it question two. So it's like crystalline silicon, then we have thin film, then organic and DSSC, then we have peroxide and all. and we have seen fabrication process, and it's all about the weekend. Now I'm moving to the content of this week, and first thing we have vacuum. Just say about whatever you know. Okay, let's take a hint. Just say in terms of pressure. Let's say if this is a bottle, and I say there's a pressure outside, the pressure inside, relative pressure. Vacuum means the inside is atmosphere pressure. Because if there is no air, then the pressure will be very less. So in terms of pressure, we can say when the pressure inside any chamber is lower than the atmospheric pressure, that is vacuum. But it depends how much it is as compared to atmospheric. Then we can say it is low vacuum, high vacuum, or ultra vacuum. And why we need this vacuum? Because if we are depositing anything on this solar cell, let's say solar cell, and some particle you want to deposit on this, so there are so many particles in the atmosphere. So the material you want to deposit, they will interfere by these materials. Even there are H2O, like humidity, that may can react. Have you heard something about like 760 mm, 1 bar, Pascal, Torr? So have you heard about all these units? Yes or no? Yes or no? You can write in the chat box. It feels me like I'm disconnected.
Sir, we are chatting, but we are not seeing.
The system, and as here, these are the relations between different units. So one atmospheric pressure is 760 mm of Hg, and the measurement can be done. It's like we have one special instrument having Hg, so it will show 760 mm level of Hg at sea level. So we usually say at the sea level we have 1 atmospheric pressure. So it is 760 mm of Hg. If we convert into bar, it will be 1 bar and 10 to raised to the power 5 Pascal. And if we convert into different units, so 1 mm of Hg we can say 1 torr. And we can convert it into Pascal as well as millitorr, then millibar, and then Pascal. So these are some internal conversion of different units. So vacuum is a condition when pressure inside is less than the atmospheric pressure, and that pressure is measured in terms of different units. Those are given here. How do we create vacuum? Have a Costco bowl, cut it, we just flip it like this, and we put it. That is nothing else. Yes, yes, we know they have done it. Okay, great. So why it is being done? Okay, you are writing the chat box. I'm sorry. Absence of any particle. Yes. Pressure less than atmospheric bar Pascal. Yes, yes, yes. So in this case, what we are doing, we are just removing the air, and here also we just need a special kind of instrument which can take out this air outside but prevent the air which can come inside. So it will prevent this one and it will be okay with this. And for this purpose, we generally use pump. And then there are different kinds of pump, but that is not related to PV. Those are about this mechanical engineering and all. But you can have a look on those types of pumps. Just you need to understand we need a vacuum, and for this vacuum creation we need something which can suck up the air and can prevent the air which might come back to the chamber, and then the chamber will become a vacuum chamber. Okay, let's move. Oh, so in this in this week we don't have much thing. Other than that, we have like scanning electron microscopy. That is nothing else, a kind of microscopy. We can say the optically we can measure with less resolution. So to increase the resolution, we use electron in the place of photon. So we have now some few questions, which we will go through those questions now. So first question says the atmospheric pressure is options. D 1 torr. I think you forgot this. It was written like 1 atmospheric. Yes. 1 atmospheric pressure equals to 7. It will be 760. So answer here. Next question is related to like spectroscopy. So if you have gone through the lectures, you can solve this question. It says the value of n in the constant phase element is, and these are the options. V. Yes. So you can see here it is n equals to half. So answer here is B. Next, just need to tell me A, B, C or D. Z, A, C. Is it? Yes. It is B. Here you can see that. Yes. Some animations from friends here. Just have a look. So wait a minute, I'll share you. So first we will see this. It is a rotary vane pump. So these are some animations. You just need to look. Now we have one scroll pump. After this, we have this diffusion pump. Then we have one this turbo pump. So in this turbo pump, we have like measurement device. So it is Pirani gauge. Gauge is a device which is used to measure the vacuum. So here you can say it is low vacuum, medium vacuum, high vacuum, and ultra high vacuum. The units here it is written in Pascal. So it is all about pressure. How much pressure there is with respect to atmospheric pressure. So this is Pirani vacuum. It is based on the Wheatstone bridge, which you have must read in the class 12. So electrical current is coming here and temperature is increasing. And last we have this.
Hey, what's up? The penning ionization gauge, also known as cold cathode gauge, is a device used to measure vacuum. It operates in a pressure range between 10 powered minus 2 and 10 powered minus 9 torrs. The system consists of a hollow anode, cathodes, magnetic poles, high voltage power source, and an emitter. When an electrical potential of 2000 volts is applied between the anode and the cathode, then gas discharge occurs. Basically, there are always some ions present in the gas, and those ions are accelerated then towards the cathode. Upon interacting with the cathode, electrons are emitted and accelerated towards the hollow anode. Thanks to magnets, these electrons move spirally and spend more time in the open, which increases their chance to hit the gas molecule to ionize it. The emitter is used to measure the ion current, which is converted into pressure units.
So we were doing some questions, and I just showed you some animations which were missing from the PPT or lecture. So the pump can be used for this diffusion pump, which can be it's like there are so many particles you can understand like this, and then you need to move them. So how you can move them? Can you use a rotary vane pump? Rotary vane pump switch to rotary. Next question is about the conductance in viscous flow. We just need to identify the correct formula for the conductance viscous flow. A, B, C, or D? It was already mentioned in the lectures. If you haven't gone through it, you can see this is the formula for conductance in viscous flow. Yes, it is A. 1.38, yes. It is not, it may be 10 raised to the power 2, 2, yes, 4, yes, not this. So answer here is A. Then we have next question, which is about the screw pump is an example of. So screw pump is like we have some screw type rotor which rotate, and these are the microscopy, and it is same, it is scanning electron microscope. So the depth of it for this, it is 4 mm to 0.4 micron. You can see the change in the difference in the image. It is an optical image and it is an same image, so it is much clear as compared to this. Yes, answer is B. Next question, which says which gauge is cold cathode type gauge? We have just seen the video, even you can answer based on the video. Is it Pirani, panning, thermocouple, or none of the above? B, panning. So this is Pirani and this one is cathode related is panning, and one more we have, it is based on thermocouple. So it says cathode type, then we have two cathode here, it is known as cold cathode type, so it is panning. B. Yes, B is the answer. The next question, it says in electrochemical impedance plot the peak frequency is defined as. So it will be 1 upon. Yes, is the correct answer. So we have completed the assignment for discussion for this week, and even this course has been ended. So this was the last question for today, and next slide we have just about the feedback if you have some. And if nothing, then just have a good day and keep learning. Maybe we will meet in the next lecture or next course in the NPTEL.
Hello.
Yeah, hello.
Am I audible, sir?
Yeah, you are.
Sir, for the assignment 7, there was a question related to the relation between solubility and temperature.
Okay.
Inverse the supply is better based on the concept of something better.
You are not very clear. Can you write in the chat box?
Okay, sir.
Others, if you have anything to say, anything to ask, you can stay here. Otherwise, you can leave. We are done with the class. In the last class, we don't have much related to PV. It was already only related to the conditions we need for fabrication of a solar cell. Yes, Chandan, you are welcome. Thank you, everyone. Inverse temperature. You are welcome. Vinod, you are asking inverse crystalline. I am not getting your point. Thank you, Madhumita. Yes. Okay. So it's like, I just will try. It's like if we have, let's say, water, and you have anything, let's say a road like this, and this water is very cold. Sorry, it's not cold, it's hot, and which is being cold, like the temperature is reducing. If you will put something like this, one rod here, so what will happen? The solubility, means it is in soluble form, we can say. It will start crystallize, means with temperature the solubility is decreasing. That's why it is coming in the solid form. Why we are having ice at less temperature or with decrease in temperature? Why? It was related to which thing? I just want to use the same liquid. If we have a water with, see, if there is high temperature, so solubility will be high or less. Let's say you have glass of milk. Yes, if you have a glass of milk that is at, let's say, high temperature, and one is at low temperature. So if you are solving some sugar, so it will be soluble much faster in hot, high temperature milk as compared to low temperature milk. So if temperature will decrease, let's say temperature is decreasing, what will happen? The solubility will decrease. So in that case, the solute which is here, you can get this. Means, answer key. Let me check what you are saying. It is from which week? 7. Okay. Question number 4. Vinod, I got your point. The answer there is solubility increase with increase temperature. Let me open for you.
Hello, sir.
Yes,
Am I audible now?
yes, yes, you are.
Sir, in my correction, in my assignment correction, they have put it as wrong. Option A.
Okay,
Actually, option A says that solubility increases with increasing temperature.
yes, that is the answer.
And we have discussed the same question last week also.
Yes, yes.
But in the key it is given as wrong. The answer is given as wrong.
Okay, then
That is
you can just raise a dispute on the portal as well. They will correct it.
okay. Nothing worry. No worry, sir. I just want to make it clarified. That's all.
Okay, okay.
And one more thing, what is the relation between band gap energy and dielectric constant? Whether it is epsilon raised to -2 or epsilon raised to -1?
Sorry, band gap and
Band gap energy and dielectric constant.
dielectric constant.
Yeah.
I need to check which question you are talking about. Is it question?
Yeah, it was a question for the same assignment, question number 7. Assignment 7, question number 7.
Okay.
What is the dependence of binding energy? Sorry, not band gap energy, it's binding energy.
That what?
Binding energy and dielectric constant.
Yes. Yes, question number 4 is incorrect. It should be solubility increase with increasing temperature. So you can
Okay.
raise one dispute here. Second one is about
Question 7.
binding.
Epsilon raised to -2 is what we have discussed last week. But again, they have given it as epsilon raised to -1 and put my answer as wrong. Okay. I should go to the portal now? Where should I find the where should I put the dispute to get my more corrected? Okay. Okay, sir. Okay. Okay. Thank you. Thank you, sir. Thank you very much. Bye, sir.
If you have any question, you can ask. I'm in this class. Have a good day. Keep learning. Take care. Bye bye.